Well, good evening, everyone, and a very warm welcome to the 5th Sir Edward Heath Lecture, which takes place annually at different universities across the country. And the Heath Lectures are organised by the Sir Edward Heath Charitable Foundation, whose mission is to empower public debate on contemporary issues with lessons from the past half-century since the Heath government of 1970 to 1974. And thank you to Neil Carmichael, who's in the front row, for enabling this year's lecture to be held here at the University of Nottingham. And Neil, of course, is an alumnus of the university, so we're really grateful to your support. For those of you who don't know me, I'm Jeremy Gregory, Pro-Vice-Chancellor for the Faculties of Arts and Social Sciences, and it's my very great pleasure to welcome Lord Willetts to deliver this evening's lecture. For those of us working in English universities, David Willetts has been one of the most thoughtful voices on higher education matters for the last 20 years and has been a significant politician for our sector. He served as Minister of State for Universities and Science from 2010 until July 2014 and became a member of the House of Lords in 2015. His university education is an impressive analysis of opportunities and challenges for the sector. Lord Willetts is President of the Resolution Foundation, and he was appointed Chair of the UK Space Agency's Board in April 2022. And this brings us to the theme of tonight's lecture. The challenge to streamline Britain's space policy was taken up by Heath's government in the early 1970s. Heath, like Macmillan before him, was pushing for the UK to join the European community, and there was a broad welcome for Heath's Minister for Aerospace, Michael Heseltine, when he resurrected the idea of and strongly argued for a European space agency. One of the themes of the last 40 years is the relationship between UK-funded space activity and that of the wider world. The UK Space Agency was established in 2010 and took over responsibility for government policy and key budgets for space exploration. As society and the global economy continues to brace itself against years of austerity, the pandemic, climate change, and mass migration from geopolitical unrest, it's never been more important for our governments, public agencies, universities, corporations, and cultural organizations to collaborate as a stabilizing force. And our university, as the UK's first truly global university, with 2 campuses in Asia, now 76 teaching partnerships worldwide, and hundreds of research collaborations from Adelaide to Los Angeles. Wouldn't it be nice to be in one of those places now? Well, perhaps not Los Angeles, but certainly somewhere warmer, is an intricate part of the tapestry that is maintaining internationalism in an age of increasing state-on-state hostility. And of course, the UK Space Agency is a principal figure in the big picture. The UK Space Agency's National Space Strategy sets out an ambition to make the UK one of the world's most innovative and attractive space economies. And for decades, space science and technology have shaped how we live, work, and understand our world, from satellite TV and navigation to smartphone apps and climate science. Today, our way of life on Earth depends on space. Tomorrow, space will help us to forge a greener, smarter, and more inclusive society. Therefore, we are proud to have been able to showcase some of the University of Nottingham's space innovation today, both through the work of our Rights Lab researchers who are working with satellite imagery to identify modern slavery in supply chains for major corporations from Wall Street to the City of London. But also, we've been able to showcase our research into black holes through the Cosmic Titans exhibition, which has been curated by Lakeside Arts together with our astronomy researchers. And if you haven't seen it already, I'd urge you to spend an afternoon in the gallery. And it reminded me of the joy of working in universities today. But all this is just the tip of the iceberg of how the UK's space strategy can make the world more stable and the UK resilient against some of the forces at play. And I therefore warmly invite Lord Willetts to give his lecture on beyond the horizon, the UK Space Agency as an engine for growth and security. David.
Well, thank you very much indeed for that introduction. It's great to be here in Nottingham at the university, and my reasons for why it's particularly significant are rather complicated. I'm going to spend the first 2 minutes explaining all the different forces and chance events that have converged on my being with you here today. One, of course, is that I'm thinking back to my time as Minister for Universities and Science. I am proud to say I've been to all of the Nottingham campuses, the University of Nottingham campus here I've visited several times. I've also been to Nottingham Ningbo twice, and I've been to Nottingham University's campus in Malaysia. And that tower, that distinctive Nottingham Tower, is a wonderful motif to see around the world. Nottingham University living up to its great ambition of being a university that serves the world. There's an even more personal reason why this matters to me, which is I've come today accompanied by my wife, Sarah Butterfield, whose father was the Vice-Chancellor here about 50 years ago. He was a medic, he'd been Professor of Medicine at Guy's, and came here with the task of expanding the medical school, which at the first was only doing the first 3 years. His task was to add years 4 and 5, so it was a full medical school. And we have just this afternoon been back to Highfield House, which is where Sarah spent some of her teenage years when it was the Vice-Chancellor's residence. It's been put to much better use since, and was a student at People's College, Nottingham, and then went off to study architecture. So for Sarah and me, it's been a very personal return. And then, of course, also, for me, with my interest in space, seeing wonderful examples of how space, instead of being seen as belonging exclusively to the physical scientists who make it all possible, see how Earth observation from satellites being used to track down modern slavery and to ensure that it's going to be possible to track the places where, sadly, there are people engaged in forced labour, and ensure that through sharing that information more widely, consumers who care about those things can avoid ever finding themselves buying goods and services linked to that. So it has all been wonderful. Great to be in Nottingham, and great to be delivering a lecture in memory of Sir Edward Heath, because when I was first elected as a Member of Parliament in 1992, my first job was as a government whip, and each whip is allocated a flock of 30 or so MPs that we look after. It's a friendly HR function, but we have to know what's on their minds, and you also have courteously to try to nudge them, perhaps to vote for the follow the whip. And I have to say, one of my challenges as a whip was that in my flock was Sir Edward Heath. So my job as a junior backbencher was to whip the former Prime Minister to vote for the government on controversial issues, which was a challenge, and I was suitably deferential to Sir Edward. I would see him, and I explained to Sir Edward there's going to be an important vote a week on Thursday, and the Prime Minister would really appreciate it if you could spare the time to come and vote. And he might say, I'll be in China. Or he might say, I will rearrange my diary and attend. So I had 18 months dealing with him, and he kindly hosted me for lunch at his wonderful house in Salisbury, and I got to know him a bit, and of course his private persona was far more witty and humorous engaged than his public persona. So all these things come together to make it, for me, a wonderful opportunity and a great privilege to be delivering a lecture in honour of Sir Edward Heath at the University of Nottingham. And I'm going to do my account of where we are on space in 3 parts. I first of all just want to tell you why space matters today. I'm then going to give you a little bit of history which will bring out the contemporary relevance of the policy issues that Edward Heath wrestled with in space, and then a bit of future speculation about where things are going and what Britain's role could be. But first of all, I do think space is now at an inflection point, not unlike what is happening in AI, or perhaps you could argue in genomics. There's a very significant change happening in the access to and usefulness of space. And let me give you the key metrics that explain how significant this inflection point is. Back in the days of the space shuttle, in the 1980s and 90s, it cost $65,000 to get a kilogram into space. Because of a series of innovations led, it must be said, by Elon Musk, in his latest SpaceX Falcon rocket, the cost of getting a kilogram into space is now $1,500. So there's been, just like the kind of advances you see with Moore's law in electronics, there's been a big change in the costs of getting stuff up there. The cost has fallen by 95% compared with what we were familiar with 30 years ago. Secondly, miniaturization means that the amount of electronic activity, the amount of data you can absorb and handle and transmit in a given space, in a given object, in a given satellite, has shrunk massively. And indeed, the extreme example, and I've seen it, is you can stick a smartphone into a little basket and launch it into low Earth orbit, and it will function for a while. You'll be able to get useful things out of it. What it is not is radiation hardened, so it won't last very long, but you've got down to the scale where some of the very miniaturization that has affected our personal use of electronics is also changing very effectively what we can do in space. And the result of that, thirdly, we've got small satellites, lightweight satellites, low cost of launch, capable of packing a lot of information into these small satellites, so there's many more of them. And in the year 2000, there were approximately 1,000 functioning satellites. By 2020, we were up to about 3,000 functioning satellites. There are now 9,000 functioning satellites, and on some forecasts, by 2030, there will be 60,000 functioning satellites. So you've got a massive fall in the cost of launch and a complete transformation in the number of functioning satellites, especially in low Earth orbit, because they're smaller and very effective. And two very smart guys are at the forefront of delivering these changes, Elon Musk and Jeff Bezos. And too much of the British coverage talks about this as if it's a kind of expensive hobby for billionaires, a sort of quixotic way of spending their enormous wealth. It is not. It is a key part of the corporate strategy of Tesla and Amazon. This is the ultimate competition between a car-based service and a home-based service. And what each of them wants is a fully integrated information and communication system which is ultimately accessible and collects data from the key products they sell. For one of them, it's via Amazon and Alexa, and for the other, it's via every car. It is a classic American competition. This is the car v. the home, as each of them the core for a completely integrated communication and service business which have got satellites and their own network, their own constellation of satellites as a key part of the project. So this is corporate competition at the highest level. It is not a rich man's hobby. So, and that's why, I mean, the space sector is already estimated to be about $500 billion, and there are forecasts that it'll be $2 trillion within just a few years. So there's a lot happening. That's why it matters today. Now I'm going to step back and take you through a tiny bit of history. And there are different ways in which you can measure the start of the space age, but a reasonable date for the start of the space age is the 8th of September 1944 at 5 Staveley Road, Chiswick. And in Staveley Road, Chiswick, on that date, one of the first V2 rockets landed in a London domestic street and killed 3 people. The first people killed with a ballistic missile attack that had gone up into space and come down. And you could argue, and there is a little memorial there, and on the 80th anniversary it was marked, you could argue that was the point at which space became real. And incidentally, the government, not wishing to create panic, it was officially described at the time as a gas explosion, not what it really was, a rocket attack from Germany. And of course, after the war, we have both the Brits and the US wanting to use the extraordinary expertise of Wernher von Braun and others, and I'm going to go through all that very quickly. Britain was developing our own rocket, and a theme that will come back all through the accounts of space. The aim was to have a rocket that had both a civil and a military use, dual use. So much of space is dual use. The problem was that the military requirements for a rocket launch, namely one that can be launched at short notice, make it very expensive compared with a civil rocket which you can plan to launch and do not need an urgent response function. So by the 1960s, the government had given up on the idea of the expensive rocket launch. For military purposes, it would use US rockets, but was still trying to develop a civil rocket. We did have, in 1962, the launch of Ariel, the first British satellite going into space, launched using a US rocket. We didn't yet have the capacity to launch it ourselves. It was launched with an American rocket, and 6 months later, one of the last atmospheric nuclear tests in the atmosphere destroyed it. I always say that kind of summarizes the special relationship. We only get there because of them, and then it gets destroyed. But Britain kept on developing its own rocket for civil use. First of all, Blue Streak, then it became Black Arrow, and was planning to launch Black Arrow from Woomera in Australia. And then Edward Heath wins the election of 1970, and this British rocket was going to launch a British satellite named Puck, Shakespearean Puck, because Puck is described in A Midsummer's Night's Dream as a merry wanderer of the night. Then Heath comes in and decides this is too expensive a program, and he and his junior minister in the Department of Industry, Michael Heseltine, decide we can't afford a unique British program, so announce they're closing down the UK rocket launch program. However, the satellite is already on its way to Woomera, the rocket is there, so they decide at least to go ahead with the launch. And the launch happens in 1971, but for the arts graduates amongst you, someone ingeniously thinks we shouldn't call it Puck. This is now the end of a program, and it was renamed Prospero. And it was launched as Prospero. Our revels now are ended. So we did have one launch of using a UK rocket of a UK satellite, and we are the only country ever to have had the capability of designing a rocket and launching our own satellites, and then to have renounced it, which is what we did in 1971. Now, what do Hezza and Edward Heath do then? Hezza thinks that it would be a great tragedy if we just completely, give up on this program, but Britain can't afford to do it on its own. So he gets together with the French and the Germans. It's the EU member states plus the UK to create a new intergovernmental organization, the European Space Agency. The European Space Agency was a British creation led by Michael Heseltine, to deliver European collaboration in space. It was finally created in 1975, so this year we're marking its 50th anniversary. And the first director was a Brit, Roy Gibson, and I was very pleased last summer to host a party in Parliament to mark Roy Gibson's 100th birthday, with Michael Heseltine there to join the celebrations. He is the only director, Director General Roy Gibson, that we've had of the European Space Agency, and he and Michael Heseltine deserves the credit for creating it. And as the EU grew, what happened was that ESA became essentially the R&D arm of the EU. The EU did not need to create its own space capability in developing stuff because it got the ESA. But when the ESA had established an Earth observation function or a satellite communication function with a couple of prototypes, then the EU would take this on and put it on its budget and say, right, we'll have 25 of those, please, and create a European constellation like Copernicus for Earth observation, or like Galileo for communications and position, navigation, and timing. And it still functions to this day. Its biggest single disruptive event was Brexit, because suddenly the balance in which it just is the EU's research arm, which works when its ESA is basically EU member states plus Norway and Switzerland, once you have a very large member, the UK, that is not also a member in the EU, that destabilizes the model. And there is now a very lively debate in Brussels about the extent to which now the EU does need to create its own space capability, because the ESA membership is now so different from the EU membership that you can't just use ESA to do all your R&D. A live topic to this day. So, and I think I mustn't go on too long about the history, but you've already seen in my historical account two threads that run through space policy to this day. One is, to what extent can you combine a civil function and a space function? And another is, what can you expect to do on your own, and where do you turn to others? And the UK ends up with a very unusual, distinctive model, where essentially, for security purposes, for the use of space for security, for the launch of our nuclear deterrent, our security partnership is with the US. And for civil purposes and the commercial development and the use of space for peaceful purposes, our partnership has been historically through ESA with the EU. A military link to the US, a civil link to the EU, and extraordinary that Britain has been in a position to play and to have used both those relationships for different aspects of space. Now, let me turn to a little account of where I think we are going now. And I'm going to take you through the steps, starting closest to Earth with launch and ending in the far reaches of the solar system. And I'm going to do it all in about 20 minutes. So the different challenges that we face. First of all, and challenges looked specifically from the perspective of what the British angle is. Now, first of all, launch. If you're trying to launch a great big heavy satellite and send it high up into geostationary orbit where it can be poised and observing the Earth and delivering perhaps communication services, but maybe 20,000 kilometers up, 30,000 kilometers in some fantastic Lagrangian points. If you want to get a great big satellite up there to do something like that, you basically want to use the Earth's rotation to help give you maximum lift. So you want to launch from the equator, and you want to launch out eastward, preferably over ocean for safety. So the world's, or it could be desert, so the world's main satellite space launch centers are clustered close to the equator and are in Cape Canaveral, of course, we all know, in Florida. The European launch site is in French Guiana. The Russian site historically was in Baikonur. However, Once you move to lots of small satellites in much lower orbit, a few hundred kilometers above Earth, and many of them, you're not trying to get into some stationary position a long way up. You are moving over the Earth. In fact, in a way, you are stationary and the Earth is rotating underneath you. You're very likely to be in polar orbit. If you're trying to get a small, lightweight satellite into polar orbit, you start looking at very different launch locations. You think somewhere quite close to the pole, near the ocean, launching due north, that would be really handy for getting some small satellites into polar orbit. So there is now a new space launch race, and we have a strong candidate in Saxiford. Saxiford, which is at the northern tip of the most northern island of the Shetland Isles. And if you launch due north from Saxiford, there's no dog's leg, there's no tricky airspace to navigate around. You can fly due north, straight over the North Pole, down the other side, and the first land you go over is New Zealand. Now, the Norwegians are developing a site, the Swedes are developing a site. The Americans, of course, have some sites, but those are in Alaska, landlocked parts of Alaska, harder to reach, and for the Americans, some of them uncomfortably close to Russia. At Saxiford, they've got North Sea installations and infrastructure and quite a functioning harbour within 10 or 15 miles of what was originally an RAF base for flights and for radar. So we are backing the Space Agency, and successive governments, and certainly strongly this government, is backing Saxiford as a significant launch site. And I hope, this is not a prediction, this is not a commitment, but I think there's a decent chance that you will see on your TV screens in the second half of this year a serious vertical rocket launch, putting small satellites into orbit from the north of Scotland. And you look at when you see how that's been possible. We were early with a regulatory regime for this. All the regulations are written for lift, not for thrust, so you needed a new set of regulation. But equally, they mustn't be so onerous that nobody can do it. So there's an opportunity on launch. Then there are these small satellites. And I was saying earlier, there's these two great big constellations being developed, Starlink and Kuiper, by Elon Musk and Jeff Bezos. And they have extraordinary capability to deliver communication. So every Tesla will be able, Elon Musk will know exactly where every Tesla is, and there will be, the driverless cars can be tracked and everything. But these are both American systems. There is an argument that people in the West and around the world would quite like an option of a non-American LEO constellation. And there is such a constellation. It's called OneWeb, and its headquarters are in Shepherd's Bush, only a few miles from the site in Chiswick that I referred to earlier. And from that, they have got next to the old BBC TV centre, they have got one of the control rooms controlling the largest number of satellites. It's the largest control room in Europe, because the OneWeb constellation is about 700 satellites. Now, it needs investment to get onto Gen 2. The obvious thing is for OneWeb to become the European constellation. However, OneWeb has a golden share held by the British government, and the UK is not a member of the EU. There are security implications for the use of such a constellation. So the official legal position of the EU is we cannot entrust a European constellation to a non-member state, given its security significance. And one possible prize, so at the moment, the official position is there is a OneWeb constellation, which now belongs actually to a French company, Eutelsat, and there is a separate EU program to create another LEO constellation called IRIS². This is the logic of the position we've got ourselves into. If it were possible to have a defense and security pact with the EU that covered space and satellites, OneWeb could become the core of a European LEO constellation. But that requires a shift in the legal and treaty environment from what we have at the moment. And you can imagine somehow all the issues that Edward Heath and Michael Heseltine wrestled with when they were trying to create an entity that would bring Britain closer to Europe, and when at the same time as creating ESA, they're taking Britain to the EU, suddenly looks very relevant all over again. Now, there's the task of making and launching all these satellites, and incidentally, although of course you'll use places like Saxiford for a few small satellites, when you want to launch in bulk, you probably will be using still very large rockets and other launch sites. Britain has got some expertise in handling data and analysis. And I always say, if you look at how we can really extract value, it's turning this massive flow of data from satellites into useful information. And I always say, Brits are quite good at this. And what did I discover this afternoon at this university? I discovered that data that is collected by the Copernicus European satellite constellation is analysed by people here in the University of Nottingham using algorithms written here by academics and researchers at the University of Nottingham so that it can be used to identify brick kilns across India where there is the greatest risk of modern slavery. That is the value that has been added by the University of Nottingham is a smart algorithm to extract information from this data. It's a brilliant example of exactly how the Brits can indeed have a distinctive role. We have attracted to the UK a company, GHGSat, which is going to use satellite data to track, it can use it for carbon dioxide, but they're probably going to use it for methane, above all, methane emissions with geographical precision, no longer just measuring what there is in the atmosphere, knowing how much methane is coming from each individual aluminium smelter, knowing also where there are the natural emissions of methane, and using that information so that green investors can decide which facilities and factories they want to invest in and where you need to raise standards. That's the kind of thing where Britain, with our capacity to write smart software and our financial services sector, can have a distinctive role. That was the third thing on my list. So we've done launch, we've done LEO constellations, we've done Earth observation and the use of the data. Fourth on my list is the biggest single problem with all this, which is space debris. All those satellites moving fast. Suddenly, if they're moving very fast, space doesn't look like a great big empty wilderness. It starts looking very crowded indeed. And the risks of collisions in low Earth orbit are now growing. Tim Peake, fantastic guy, our astronaut who went to the space station, will say that for him, the most nerve-wracking part of his mission wasn't the classic launch or return to Earth. It was the occasions when the astronauts on the International Space Station were told to go and wait in the Soyuz capsule in case space debris that was forecast to be coming close to the space station got so close as to damage it, so they had to make a rapid return to Earth. And that is one of the risks. And what we've got, the figures here, we've got 29,000 objects, we think, that are greater than 10 centimeters. We've got 670,000 objects that are greater than 1 centimeter. And we've got 170 million objects that are greater than 1 millimeter. And the fear is of what's called a Kessler event. And that is, imagine two satellites colliding, or deliberate action by an irresponsible actor. And Russia has done this deliberately once, where you send up a rocket to deliberately destroy a satellite, and that creates a lot more debris, and that debris in turn collides with another satellite, which creates even more debris, and you end up in an environment where it is very difficult for the space station or satellites to function. Now, we have not got that precise modelling we need to know how close we are to such a scenario. The pessimists say we're going to be lucky if we can carry on using low Earth orbits for another decade. We're going to destroy our own capability to use them. The optimists will say that we can manage this and that we can promote the responsible use of space, which includes, for everything you put up, a strategy for bringing it back down and burning up in the atmosphere. And the king, our king, King Charles, who has a personal commitment to sustainability, is applying that personal commitment to space, and Britain has led discussions of this in the United Nations, and the king himself has promoted what is called Astra Charta, which is a statement of principles about making space sustainable by planning for how we should allow our satellites to deorbit. But we cannot be assured that that will work. And of course, there's another experiment which we don't, whose implications we don't fully understand, which is lots of satellites burning up as they enter the Earth's atmosphere. At what point is this going to create pollutants and create chemical reactions high up in the Earth's atmosphere that themselves have deleterious, damaging consequences? We're very fortunate to have Martin Polyakov here in the front row, and he can answer any difficult questions on that issue, I'm sure. So there's a space debris problem. That is a classic tragedy of the commons. Individuals put up their own satellite, think it'll all be fine, and then you're in danger of making the whole system unusable. And Britain can play a responsible and influential role in tackling that. So let's move on to my fifth item, which is a more optimistic interpretation. Just imagine we could handle the space debris problem. The next thing that you can start doing, now that it's cheap to get to space, and now that robotics are meaning that you can do more and more sophisticated things in space, is shift some sophisticated research and industrial processes into a zero-gravity environment. And there are people who will say that growing cells, growing crystals rapidly to a perfect shape, not distorted by gravity, is far more easily done in space than it is on Earth. So the future is probably after the International Space Station is abandoned for human use, but probably to have the equivalence as zero-gravity R&D labs and factories where cells and crystals can be grown, and you take up the raw material and you then bring it back down again a few weeks later. And if you really want to mass produce, including some cancer drugs or other, this may be the best place to do it. And we are backing, the space agency is backing a fantastic British startup run by Katie King, BioOrbit. And she understands and has the scientific knowledge that I don't have. She says that there are some immunotherapy drugs that are best produced in zero gravity, and that is the cost-effective way to do it. And I think in the next decades, we are going to see industrial, certainly research, because you can do things quickly in space, certainly research and probably some industrial processes transferred to low Earth orbit and delivered in zero gravity, and you then bring your microelectronics or whatever it is back down to Earth for use. That's going to be very interesting. That was the fifth item on my list. So I've so far talked about launch and what happens in low Earth orbit. Next on my list is the moon. Now, Britain has not historically been engaged with lunar activity. And of course, for the Americans, having got there 50 years ago, for a long time, their line was, been there, done that, no point going back. And by the way, when we say going back, been there, no point going back, there was still non-manned missions going from other countries as well. And as we think a regime for the moon, it is worth recording that we have so far left 70 satellites, broken satellites, or satellites that have landed on the moon. We have left 96 bags of human waste on the moon. We've left approximately 400,000 pounds weight of miscellaneous paraphernalia on the moon. So there's beginning to be a debate, a bit like the Antarctic. What exactly are we supposed to be doing? Do we have any shared obligations to preserve this environment? Because we're going back to the moon. And for the Americans, I think the moment of truth was when they realized that if they did nothing, the next person on the moon would probably be a Chinese woman. And they began to think what this would mean for America's position in the world, what it would say about America. So there's now another race on to get back to the moon, and encouraged further by the discovery of ice at the south pole of the moon, which is really important for making it possible to sustain a lunar base. It won't do it on its own, but it does make a lunar base more viable. And it is very possible that within the next decade or so, we will see two rival lunar bases quite close to each other, a Chinese base, an American base. And a very interesting question is, what is the legal framework that determines any interactions between them? And the people are getting interested in what we can learn from Antarctic treaties and rules and the laws of the sea to provide some kind of framework for this, because at the moment we don't have a legal framework. And sorry, just to, as another example of the problems of not having a legal framework, when you're talking about activities in low Earth orbit, it seems to me the obvious place to put data centers. So you'll put your data centers up there, and that's where the data processing will happen. All these issues about managing the heat they got will be dealt with. What is the regime for data protection for a data center that's not in any national jurisdiction? There is no legal regime. We need the ethicists, we need the lawyers to carry on thinking just as the science and the technology advances. So there's a race to the moon, and Britain is now, through ESA, playing a role in this, because we're going to have, we don't know exactly, but quite possibly 250 different lunar missions from perhaps a dozen different countries over the next 15 years or so. And at the moment, each mission takes its own communication system and all its own kit to operate unilaterally, autonomously when it gets to the moon and back. We're going to need it's going to be efficient to have a single shared lunar sat-nav system and lunar communication system. And the Brits and the Italians have got together to put the first navigation satellite and communication satellite in orbit around the moon as a test for developing a constellation so that subsequent missions, if they come from the UAE or they come from Israel or they come from India, can all use a shared lunar satellite capability. The Americans have also now putting significant investment into it. So what we've got, a smaller version of what we've got in orbit around the Earth, we will see in the next 10 or 20 years being put in orbit around the moon. So that was the next thing that's happening, which is the race to the moon. Two last steps. Then there's getting to Mars, which Elon Musk is clearly committed to, and he seems to have some influence on the American president, who was very interested in space, and one of his priorities when he was president before. You don't want a long, slow journey to Mars. You want to get there quickly, which means you want, and some of the estimates of how long it takes assume that there's not much power. You need a powered mission. And when you're looking at how you power a long distance mission to Mars, you are talking about nuclear power. And as we're all very interested at the moment in small modular reactors, but of course small modular reactors themselves are the size of a factory. We're talking about micro-reactors. We're talking about the use of nuclear power in space, which does already happen, and probably using nuclear power also to help power a lunar base through the long lunar darkness. There's a fortnight's darkness down at the South Pole, and it's very hard to have the sufficient energy storage capabilities without also using nuclear power. And if you want to go on very long missions out beyond Mars, not human missions, but you just need to keep your satellites at a sensible temperature. You need some residual power supply. Looks like nuclear is a a requirement. And the Americans have a very high opinion of Rolls-Royce's capacity to produce very small nuclear reactors. And there is a possible role for the UK in contributing our technical understanding for those sorts of missions. And then finally, there's all the discovery science and all the stuff that's happening way far out. And it's the case that, and it is amazing what is now possible, that we are now working with NASA on a Habitable Worlds project, which is trying to find around the galaxy the systems of, and particularly the planets that have, from what we understand from our own limited experience on Earth, have the best capacity to sustain life. There is, but a little bit closer to home, within our own solar system, there is, of course, always the issue of asteroids. And if I began with that date, the 8th of September 1944, let me end with a date, Friday the 13th, that's a bad start, isn't it? Friday the 13th, 2029. Friday the 13th, 2029 is when the asteroid Apophis passes closest to Earth. There was a point when people thought it would go very close. They now believe it should be 20,000 kilometers away, but the scientists are still making the estimates. And this matters. Apophis weighs 27 million tons and is 350 meters long. So staying out of the way of Apophis in 2029 is another date for your diaries. But I think we'll do it, and I'm sure there'll be very smart researchers and academics at the University of Nottingham helping us track it. Thank you very much indeed. So I think there is a few minutes for questions, if anybody does. Oh, and we've got, they're not walking out in protest, they're going to get the microphones, they're going to get the roving mics. So if anybody has a question that you want to put to me, I am not a scientist, but the scientists have been very patient in explaining stuff to me. Yes, gentleman there.
I've heard recently some talk about what the UK's contribution is going to be to NATO and how that's planned, and that we're trying to focus on cybersecurity and potentially space interpretation was the last thing I heard. Is there a separation between the UK Space Agency and the military side from where you are, or is it all one merged thing, and is this going to result in some more funding towards what we can do by funding some military capabilities?
Historically, the Space Agency is the civil and commercial and science arm. We are not a security agency. And our budget is, in terms of modern government, actually quite modest. It's about £600 million. And of that, about £400 million goes to ESO, which is also has no military or security role, and £200 million is spent on national programs per year. There is separately a military budget, of which the most important part goes on secure communication systems, Skynet. There's an endless debate about all this, but so much of space activity is potentially dual use that there are links between. Sometimes a program is of multiple use. And again, if I may say so, I had a great example of that today here at Nottingham, where one of the sources of information for tracking illegal extraction, or potentially illegal extraction of sandstone and sand deposits, is done by your right centre here, using data from NOVASAR, synthetic aperture radar satellite system. And that NOVASAR, which has the capacity to see through cloud, it doesn't depend, it's not of classic visual imagery. One of the other uses of NOVASAR is if you want to track fast-moving pirate boats in the Indian Ocean that create a wash. The NOVASAR is a great system, even if there's a cloud cover, for tracking the wash of a fast-moving boat. And so one moment its imagery is being used for people doing anti-piracy operations in the Indian Ocean. The next moment it's being used, if you think about it, it's a not totally dissimilar ripple type effect for changing patterns in sand deposits. So it's in the real world, it's impossible to completely separate these functions. Yes.
Thank you very much for that. We heard in the news today how artificial intelligence may be acquired and used by sort of non-state actors for hostile purposes, a sort of use of corrupting nuclear weapons and nuclear weapon systems. Taking that to the space situation, what sort of actors might there be out there who are non-state actors looking to corrupt the efforts for positive use, and how do you see that playing out, and what sort of level, or is it just out of the reach of any smaller states?
There are a set of threats, and it's everything from, you can of course, in those big satellites that I began with, the big geostationary satellites that are currently used for position, navigation and timing, you can try to interfere with those signals. And if you interfere with those signals, people may think they're a different place than they really are. They may think they're sending their missile or some other thing to a different place than they intend. You can also use it, you can try to use it for interrupting time signals so that a fraudulent transaction can be clocked in a fraction of a second earlier. So there's all those vulnerabilities of the weak signal, which is why the low Earth orbit constellations with the strongest signal have a crucial role to play. And then, and this is getting James Bond, but then there is going back to space debris, the threat just to make parts of space unusable. And I always say to my American friends, who are of course preoccupied with the competition from China and America wants to have dominance in space, I say it is not good game theory if America is so dominant in space that it becomes a rational strategy for China to make space unusable. Actually, China using space as well you want them to have a stake in the system rather than be outsiders beyond the system, and the same probably in some way applies to Russia as well. So, but there may be some evil actors for whom none of this matters. They will just threaten to make low Earth orbits unusable.
You partially commented on this, but since nobody owns space, how many satellites can one person put into space? Is there an upper number, or can you just say, if Elon Musk would decide to put 1 million satellites in orbit tomorrow, would that be legal?
Well, the maximum you can, of the small, when he's using his largest rockets to launch a lot of his small satellites, I think he gets about 140 satellites onto a rocket. So there is a capacity constraint. The legal regime, and it's a very fair question, there's nowhere there's no international law that says you can have, that sets a global limit on the number of satellites. Where we do have international law is on spectrum, the use of spectrum. And if you want to extend international governance of space, I would start with the entity we've already got, the International Telecommunications Union. And the other thing that would make space unusable is everybody was just randomly using whatever bits of spectrum they fancied. ITU allocates spectrum. And that is so there's only a certain bit of spectrum that each satellite operator is allowed to use. Now they can put more satellites up, but they've got a spectrum constraint. That is regulated. Yeah.
Thank you. As a co-founder of the UK AI's Trade Association, one of the things that keeps me up at night is really whether or not children are leaving school ready for the future AI economy. And one of the things that hasn't been touched on today really is about the education reforms. And given your previous brief, it'd be quite interesting to hear from your perspective how we're going to get children ready for this new space age. What sort of curriculum changes need to be made in order to allow universities like Nottingham to receive the best prospect of having high-quality students doing what they need to do?
Yeah, and look, we need students from a range of backgrounds. In terms of STEM, the two things that really get kids interested in STEM are dinosaurs and space. So in terms of just what engages them, and it is interesting, Paul Nurse coming back for a second term as president of the Royal Society, Paul Nurse on his balcony at Carlton House Terrace of the president's flat has quite a sophisticated telescope, and although he got his Nobel Prize in life sciences, he will say he first got interested in science through astronomy. So there's that does get people involved. I can't remember exactly how far this went. I think some of it happened. The other thing that I'm keen on, and some countries do more of than we do, but I think we've tried a bit, is these small satellites. The great advantage of these small satellites is they're low cost, and there's CubeSats, which may be 30 centimeters by 10 centimeters or whatever. And I think some of this already happened. But basically, run a little government program for a university or even college to have its own CubeSat. And it's a great project, and they're now so low cost and accessible that they should be possible for a group of science students in one of our large universities to say, we've got our little satellite up there and we're doing X with it. We're using it to do something. So accessibility in that way for lower cost. And I know, and I can't remember, we did have a program like that for a time. I genuinely don't know if it's still in operation today. Some other countries do that. And you can do things, and things like that and it's not just the physics and the engineering, exciting though that is. You then start saying, so what's the legal regime? And how close can you go to another satellite? And on what basis do you agree how close you can go? And is there an enforcement body? And you find a whole host of other questions come up. And what do you want to use it for and why? And is it legitimate? So it's actually it's what I like about it. It's really multidisciplinary.
And we say we just have one more question.
Thank you. I wasn't going to mention this, but since we came on to STEM and education, I'm a member of UKRA, which is the UK Rocketry Association, who's responsible for all amateur and educational research rocketry. We do a lot of outreach.
Yep.
And I've been recently trying to expand our outreach function. And I'm sad to learn that the UK Space Agency has been working with the Scouts to redesign their aeronautical badges and are removing all practical rocketry and space science aspects from it. I wondered what your position was on that.
Well, all I can say is I've learned something today. I have now, I was not aware of this issue. I'm grateful to you to bring it to my attention. I'll look for, perhaps we can have a quick chat afterwards. I will find out what's going on and to what extent this is actually a UK Space Agency responsibility and where it comes from. But I thank you so much. That's just an example of what's been happening all day, which I've been learning so much here at the University of Nottingham, and I'm very grateful to you. Thank you very much.
Lord Willett, thank you so much for a really fascinating journey through the stratosphere to understand a little more about how we work out of this world to improve the lives of billions of people across the planet. So thank you so much for your lecture and for answering our questions. So I'm now going to ask Neil Carmichael to say a few words on behalf of the Sir Edward Heath Charitable Foundation, and then I'll just come back to wrap tonight's events up. So
Well, thank you very much indeed. It's a great honour to be here, to be thanking the university for putting this lecture on. I am a former politics student here, thoroughly enjoyed my years at Nottingham, and I've been more active at the university more recently in education and in politics. The Edward Heath Charitable Foundation is really a product of Ted himself, obviously, because he entrusted his house to the public, and we look after that house and make sure that it can be accessed by the public as often as possible. But there's much more than that. What we want to do is make sure that we can talk about politics, talk about Ted's achievements, talk about the issues which are so common to Ted and now to us 50 years on. And so what we do are these lectures, for example. This is the 5th, but it's the 2nd we've done at Nottingham, because Nottingham is such a great host, and I want to thank the university for that. We also do university lectures across the whole country, but we've established a new Westminster lecture series, which starts in June with Dominic Grieve and Liam Byrne, who's actually a Labour Member of Parliament. And we're very pleased to say that, because this is cross-party with a sort of a wide range of interests. And you'll be pleased to hear we've set up the Heath Academic Forum, which is all about research, development, and thinking about ideas. But as David has really reminded us so very powerfully, the things that Ted dealt with in the 1970s are still relevant now. In terms of working together as nations, seeing what we can do within the European Union once we return to it, and also the challenges, I had to get that one in, and also the challenges of economic growth, which Ted struggled with in the 1970s because of outside influences and difficulties. And the government today is looking at the same sort of challenges about how to get the economy growing once more, how to share the proceeds of that growth, and how to make it really possible for Britain to once again stride confidently in the global arena. But to do that, we need to work together. David has shown that absolutely clearly, and the example he gave about the start off of the European Space Agency is actually an example to us all and to other nations as well. So thank you very much, David, for that. Thank you very much to the university, and you can be sure that the Heath Foundation will be doing a whole lot more to further knowledge, further understanding, and to promote the ideas that Ted Heath had, which are still relevant today. Thank you.
So just to wrap up, what a great event we've had tonight. Thank you, Neil, and thank you, David. And David, I hope you've enjoyed your afternoon and evening with us enough for us to entice you back to the University of Nottingham for a social event, but also perhaps for another lecture. And it'd be really good to have your thoughts on education over the next decade or so and the challenges that we're going to face. And it's also been wonderful to welcome you, Sarah, back to campus. And again, you're very welcome to return. I'd also like to invite you, the audience, to return and urge you to look out for the public lectures we organise throughout the year on campus. And please do share a drink with us before braving the cold journey home this evening. Wine and soft drinks are being served outside in the theatre cafe. So as I leave you with these thoughts of wine and soft drinks, please could I ask you to bring your hands together one last time for Lord Willits of the UK Space Agency and Neil Carmichael of the Sedgwick Heath Foundation. And thank you all very much for coming. We hope you enjoyed it. It's been great. Thank you.